So thank you for completing the welcome quiz. We just want to get a sense of who you are. So it looks like we're about 50-50 between STEM, science, technology, engineering and maths, and English. I wonder if I can see what the other is. Don't seem to be able to. Oh, fair enough. Okay. So about half and half, which is fantastic. So we one of the reasons for this session is to cross-pollinate between English and the sciences. Which discipline do you work mostly with? So we have a lot of mathematicians, followed by engineering and then chemistry. So that's a good mix. Fantastic. And then other. I wonder what other ones we have. If you put other there, could you just turn on your mic and tell us what you work with?
Well, biosciences mostly.
Biosciences. Any others?
Physics.
Physics. Great. All still relevant for you, and it'd be interesting to get your take on some of the stuff we do later. And then we have a word cloud. Which of the following are you most hoping to achieve today? Language. Great. That's our focus today. So I'm glad language is big there. Language of maths, content specialists, stronger insight, international students, barriers to language. Yeah, we'll hopefully talk a bit about that. Share and discover. That's definitely a key part of this session. Approaches to STEM as well. Fantastic. People. Yeah. Okay. Okay, so thanks for sharing who you are. Well, how do I get out of this? Sorry. So hopefully the outcomes that we devised for today align with your expectations. So one of the first outcome we have is intended outcome is that we can meet and connect with others working in similar areas. We want to identify areas of language and communication for further exploration. So we're hoping this might be the first session of several on this topic, depending on interest and appetite. And we want to share quick practical strategies to uncover, teach and learn this language. And that's whether you're an English teacher or a STEM teacher. We're hoping that all of you get something to take away from this. Before we continue, we should define a couple of terms. So what do we mean by hidden language? We mean the verbal skills and linguistic knowledge. So verbal skills and linguistic knowledge are things like pronunciation, grammar, but they're also things like vocabulary and style used to articulate equations and concepts that aren't evident from the written symbols alone. So we're having quite a broad definition of what an equation is. It's things with symbols in. And then verbalize, we use that word a lot. So what do we mean by that? We mean to express written symbols out loud in words. So for example, a squared plus b squared equals c squared. I've just verbalized that equation. Okay, so it's time to go into breakout rooms. Are we ready, Laura? I think Laura's going to prepare the breakout rooms whilst I just go through this task. So we'd like you to discuss in groups of 3 the following questions. You can use your own example if you brought it with you. So if you brought an example of equations that you wanted to talk about, then please feel free in your breakout room to share that with the group using the share screen function. Or if you haven't brought anything with you, or the IT doesn't work for you, you can discuss those on the flyer. There are 3 maths equations and 2 chemistry. Do you know how to verbalize, say out loud these equations? If so, what language, grammar, vocabulary, pronunciation, organization, style stands out or interests you? If not, how could you find out? What resources, people or things would you use? Okay, so we're sharing 3 bits of knowledge here. Firstly, how do you verbalize them? I would imagine that those of you coming from the STEM background will answer that question easily. 2, what language stands out? Everyone can answer that question, but of course the language specialists will have a strength there. And then 3, how would you find out? What resources would you use? That's particularly aimed at the English language specialists, but again, all of you, I'm sure, have answers to that. So in your groups of 3, we'd like one of you to record your answers on the group quiz. So when the first thing to do when you meet each other is nominate a scribe, and we have the link and the QR code for that. Any questions about your task? No. So this is the main bit of today's session. This is what we're here for, to talk about these things. So we're going to give you a good amount of time, about 20 minutes, to do this task. Laura, are we ready with the groups yet?
Did you want to give people a chance to take a screenshot of the flyer, just in case they did want to?
Good point.
Go off the flyer.
Please take a screenshot of the flyer. Also, if you scan that QR code, you'll get those 3 questions again, exactly the same questions again on the quiz.
So can you just move on to the flyer slide, move on to the flyer so that people can get a screenshot of it if they want to, if they don't have it to hand.
Yeah. Okay. 3, 2, 1. So here's the equations on the flyer. There's 5 of them. You don't have to discuss all of them. You can just choose 1 or 2, or you can choose your own equations that you've brought with you. You can make that choice once you meet your group.
F of x equals a naught.
Okay. I'm going to open the rooms and send people out unless anyone wants me to hold up for an extra moment. Okay, I'll send people out. So you should be being moved now.
Okay, so let's bring ourselves back together. So I'm going to start with the last slide that you saw. So hang on. So your task was for one of you in the group to complete that quiz. Don't forget to click submit, and you could either talk about one of the equations here from the flyer, or you could talk about something you'd brought yourselves. So let's have a look at some of the answers. So the first question was, do you know how to verbalize these equations? If yes, explain how you would verbalize one or more. If no, and leave blank or write not sure. So we've got, I'm not sure how helpful this word cloud is. Let's try all responses. I didn't, but subject lecturers did. Okay. Some of them, the maths ones, but not so much chemistry. A equals pi r squared. A squared plus b squared equals c squared. Pythagoras theorem, I think that's correct. Chemistry, pH equals minus log H plus, not sure. We'll go on to that in a minute. Is the meaning implicit? Yes, it's implicit in reading it, yes. But at some point in a student's life, someone has to explain that equation to them. So the first time they see it, it will have little meaning to them. Methane plus 2 oxygen turns into, reacts to produce. Okay, good. Oh, hang on. Let's go down a bit. Not sure. I just missed something there. 2 of us had some idea, 1 had no idea. Fair enough. Function of x equals. Oh, trying the last one, the Fourier series. Very brave. Yep. Cosine, very good. And a maths teacher familiar with all, but thanks to Sylvia for clarifying. Yeah, the molar concentration, square brackets. Thanks, Sylvia. We all had different abilities. Yes, that's what we were hoping for. What stands out to you about the language in these equations? The prepositions, yeah. Yeah, they can be quite important. And the chunks, yeah, to the power of, absolutely. Vocabulary, discourse, order of reading the equation, yeah. No linking language. I would challenge you on that, but yeah, it's different, certainly. Few transitions. These are some good points, but I think the STEM teachers would agree that when explaining an equation like this, they wouldn't just stand there and read it out like a robot and stop. They would be explaining what everything means, and they would then have linking and transitions going on. And we're going to see an example of that soon. Every symbol stands for something in these. Yes, you can't skip a symbol. Absolutely. They replace some sort of language. Do we assume the audience understands that when reading it out? That's such a good question. I'm assuming that comes from an English teacher. So I found teaching this that most of my students are at B2 level, SEFRA B2. Some of them are C1. And so if you look at the SEFRA B2, under the listening skills and the speaking skills, students can listen to and speak about familiar topics. So I would pick something where I assume the audience does understand it, because I'm not a maths teacher or a chemistry teacher, I'm an English teacher. So I'd pick something from GCSE maths or chemistry with the assumption they know what it means already in their own language, and then we can focus on the English. Depend on the branch of maths, absolutely. And the same goes for chemistry, and I'm sure it does for engineering and biology as well. So if you dig down, as Tasha knows very well, you get different conventions going on. Some of it's Greek or not English, true, but it's worth covering the basic Greek letters because they come up everywhere. And although they have different meanings in different subjects, we learn from school that about pi and sigma and alpha and beta, but you wouldn't necessarily learn that studying cutting edge upper intermediate. Okay, that's a reference to a general English course, by the way. All right, lots of good ideas here. Okay, I'm just conscious of time, so apologies if you feel rushed. We can share these answers with you later. Lecture recordings, absolutely brilliant resource. Love it. And a tip for the English teachers, as you would expect, the familiar stuff is normally at the beginning of a lecture. So STEM lecturers, whether it's maths or chemistry, tend to start with something familiar and then blow the student's mind with it being much more complicated. So if you look at the first 10 minutes of a lecture, you often find some good material. Ask Anna. Who's Anna? Who's Anna?
Anna's here. She's here.
Sorry, it's me. She's IAP
She's
teacher
the
and I am
maths
a teacher, but my second language, English is my second language, so that's the reason that she said that.
Perfect. So you sound like a really good resource, Anna. So definitely working with each other. That's why we're excited to have everyone here, because we feel that all of this is so much more doable if we collaborate and talk to each other.
Definitely.
So yeah. Oh, sorry, I keep doing the wrong thing there, so I don't mean to do that. Google. Yeah, Google. A few people have written about Google. AI, yeah. Able I can verbalize all of these. Yeah, so I found AI very useful myself, and I've worked with James, who just left here there, to check, because I found it's quite accurate actually. James has generally said yes, that's accurate, but there's a few things that it might get wrong or sound funny. So AI is very good. Verbalize this equation. Or explain this equation like you are a maths teacher. Those are good prompts. Ask subject colleagues, absolutely. Create your own corpus. Oh, yeah, I'd love to do that, but at the moment don't have the resource. Has anyone done that in this? I know people have generally, but has anyone done that in this session, this group? Alistair?
Yeah, we did it with maths lectures when they went online during the pandemic. It was just one semester. No, we recorded both actually, 2 semesters now. Yeah.
So 2 semesters of lecture transcripts.
Yeah, undergraduate maths here in China.
Oh, yeah. Fantastic! And do you use it? Has it created some materials?
Yeah, we were looking more at vocabulary. So particularly sort of polysemous words, mathematics words, and then we were working with a content lecturer. So he's done a little bit of kind of language within his classes, based on what we found really.
That's fantastic. And is this something that can be shared outside of your institution, or is it just within your department?
I'd probably have to go back and get permission to share it. I think.
Of course. Yeah. It'd be interesting to know how you went about making that corpus. So in a minute, we're going to ask you for what you'd like to do for future sessions. So if you thought that was interesting, that possibly could be a future session. How did Alistair, or if Alistair's not interested, then how does one make a corpus? I'd call that a mini corpus. Would you agree, Alistair?
I think it was 150,000 words, something like that. So it wasn't really massive. It wasn't millions.
Yeah. So a lot of words, but not millions. Yeah.
Yeah.
Fantastic. Okay. I'm going to move us along. We've got 10 minutes left, so I just want to talk about a few things. So first of all, we thought it'd be cruel not to show you the answers. An answer. So verbalizing maths first. So we got a squared plus b squared equals c squared. And a few things to notice. Notice that squared is in its verb form. So verbs are often important in this area of English. And we note that because it's often taught by ESAP, and I've noticed, and I'm sure you have too, but the ESAP vocabulary lists tend to be noun heavy, feature very few verbs. But when it comes to this area of science, equations, verbs are quite useful. A equals pi r squared. Notice the Greek letter pi is pi, so covering Greek letters is worthwhile, particularly the really common ones, how they're pronounced in particular. This is the Fourier series, which is high-level maths. What level would you teach this maths at? It's certainly not high school. Any mathematicians here? When would you teach the Fourier?
First year university.
First year university. Okay, so
or further maths. So that's sort of the overlap.
So this would only really be familiar if you were doing an English class with 3rd years or masters. Would that be right? For first years, this would be unfamiliar.
No,
would that
well,
be correct?
First year undergraduate, they would do it. Yes.
Yeah. But they're learning it for the first time, right?
Probably, yes.
Yeah.
I would imagine. Or it's further maths. As I say, it's above my pay grade.
Yes, okay. Oh, Edward. Hi, Edward.
I was thinking, obviously, there may be a difference between being able to plug it in and use the formula versus like it becoming analysis later on and being able to prove it.
Yeah, so
it might come at multiple stages as well.
Edward, are you a maths teacher?
No, so STEM EAP.
STEM EAP. Okay. Do we have any maths teachers here? Could you explain to us how you would how this equation would work in a classroom if you were either teaching it for the first time, or maybe if you're doing a revision class just before a test? Anyone feeling brave? Anna?
Go on then. Hello.
Hi, Anna.
So I suppose all math students would be familiar with certain elements of this. You know, we teach functions probably in GCSE, so f of x equals, most students could grasp. The capital sigma, the Greek letter, sigma sum to mean sum, that's been brought into A level, or even AS now. But I might encourage students to say, well, can you read this to each other and then, you know, model how to say it? This is A naught plus the sum from n is 1 to infinity of. And then inside the bracket, you've got this sum of trig terms. I made the point that when you press cos, cosine, or sine on a calculator, it automatically opens a bracket, telling you that you need to know what you're taking the sine or cosine of. The angle is the n pi x over L. But like Edward said, there's a difference between students being able to use and substitute in values and really grasping what this formula is telling us. Sorry, what was your actual question about how I'd present this in class?
Yeah, so we're half the group here are interested in all the language. So we're interested in how these symbols are pronounced, which is what we really focused on with the first two equations there. But also, that's half of it. The other half is how you would go about explaining it, because you would teach this probably over several classes.
That's right, and all the maths prior is building up to, so you know, function notation, the beginning of that, f of x, we're taking an input value x and plugging that into a known rule or formula to get an output. So just that concept is one thing students need to be familiar with.
Yeah, so that kind of language is also interesting to us. And then how would you be doing? Would you be on a blackboard or whiteboard writing this out as you speak?
Yeah, or likely have it up already and use color to draw attention to the actual angle part. Use of brackets. You can have curly brackets or square brackets to focus on. Obviously, inside that summation, you've got an expression. And I would spend time helping students learn the difference between an expression, an equation, a formula. All these have different nuances. And then you could put more brackets around the n pi x over L, because all of that is the angle that you're finding the cosine, cos of, and then the sine of. That's finding the ratio of the adjacent to the hypotenuse. There's so much you can unpick, and there's so much assumed knowledge that you've hopefully covered before with students.
Yeah. And what's your body? Oh, sorry, Laura.
Sorry, I was going to say I find it really interesting hearing you hearing you be able to talk about it, because I can't understand that equation at all, or wouldn't have any idea how to say it. I'm more like to focus on the language on either side of the equation that comes before and comes after, and then tend to just leave this bit for the students to you know, explain or understand themselves. But hearing you read it out, you know, the fascinating the bits where you do have the prepositions in the f of x, but then also the bits where you've just got a string n pi x, I think you said, you know, the three different bits back to back, and you know, just comparing that to what I would generally be looking at them in another part of a, you know, a sentence of nouns and compound nouns or different things, and then we've got this string of n pi x, these three bits just put together, which obviously is what happens in the equation, but then we sometimes got of, we sometimes got over, and that relationship between them in other places. It's just really interesting hearing the, you know, the language that you use when you are. Of
course, that was implied multiplication, yeah, when they're next to each
other.
Yeah,
exactly. Yeah.
But
just being able to listen like that. Yeah, but it's interesting. Thank you. Sorry,
okay.
Evan.
No, it's okay, Laura.
Got too excited about the languages.
It's so exciting, isn't it? It's always happens to get excited 5 minutes before the end. So Anna, thank you for sharing. I'd be interesting to see if you use some of the language we have on the next slide. So here we've got, notice the synonyms. So over, Anna, correct me if I'm wrong, but I think this is true. Over for divided by, and silence or times for multiplied by. So we say n pi x over L. Is that right? I think it is. Let's move on to chemistry. So chemistry, like maths, we can just verbalize the equation, but here we want to introduce with the chemistry ones this idea of transitions and linking language and stuff. And Anna, I'd be interested to know if you use similar language in your subject. So here we have Sylvia, just to pick on you because I know you're here. How would you say this, Sylvia?
I'd say pH equals to minus log of molar concentration of H plus.
Brilliant. Thank you.
I hope it was correct.
Yeah. So that, well, do you know, not me. How does this look? Tell me what you think about this. I'll read it out. All right, let's look at the equation for pH. pH equals negative log of H plus. pH here tells us how acidic or basic a solution is. Negative log means we're taking the logarithm base 10 of the hydrogen ion concentration, H plus. The square brackets around H plus mean the concentration of H plus ions. How does that sound to you, Sylvia? Does it sound quite natural? Does it make sense? Or any other chemists that are in the room?
I could see only myself from chemistry.
Oh, right. Okay.
I mean, I don't recognize anyone else.
Okay.
I don't know.
So here we you can notice the prepositions which are mentioned earlier. So we've got the concentration of H plus, or back to the equation, pH equals negative log of H plus. I think you added a few words in there, didn't you, Sylvia, like molar concentration of
Yeah, I
H
think
plus?
it's important to specify molar concentration because you can measure concentration with different units. So the equation tells us that you need to use the molar one and it needs to be read out.
Okay. So that's really useful. So that this explanation here was generated by AI, and I did not check it with a chemist. And now a chemist is coming along, thank you, Sylvia, and pointing out things that would make it more authentic. And then we have this equation here. Let's look at this equation. Methane plus oxygen reacts to form carbon dioxide and water. On this side, I'm pointing to the left. CH4 is methane and 2O2 is 2 oxygen molecules. Over here, CO2 is carbon dioxide and 2H2O is 2 water molecules. Don't forget this is a combustion reaction. Methane burns an oxygen to produce carbon dioxide and water. Does that sound okay, Sylvia?
I think the first sentence is okay, but when it goes into details, because when it reads 2O2, it doesn't say that it's 2 moles of oxygen would react, for example, with a mole of methane. It's a bit, the explanation is a bit confused. It's not clear.
So it's interesting you'd use moles anyway, not molecules.
Yeah, you'd say moles.
Much more natural.
Yeah.
Yeah. So these two should have been checked with a chemist before revealing them to a whole group of people. That's my bad. Yeah. So notice the informal style, let's, and locating language like here. I wondered, Sylvia and Anna, is that the kind of language you use when you're explaining these equations, breaking them down, teaching them for the first time, or revision sessions?
I would, yeah. I would say, let's look at this equation.
And Anna?
Yes, absolutely. Or even ask students what they think. Sorry, I do need to teach now. Oh, it's so difficult to leave this wonderful meeting, though. Thank you so much.
Thanks for coming, Anna. I better hurry to the end then. Okay. So I've got a summary here which we can share later. How can you find out more? Lectures of peers, your students, resources. Some of them have been mentioned. So AI tools, online video tutorials, the dictionary. Thank you for joining us. We hope you've met and connected with people. We've identified some areas of language and we've shared some practical strategies. Next steps, please stay connected. You can join the conversation and explore future events. Visit our BALEAPSTEMSIG.org for resources and updates. Rosa?
No, I meant to applaud, sorry.
Okay, sure. Right.
Well done.
Our next event is next month. We've got another Tea Times Teams Meet, misconceptions about STEM at 11, and then we have our AGM at 12 GMT. And then future sessions. What would you like? If you were interested, what would you like to explore further? There's the language in the classroom, which we've talked a lot about today, but there's also language and research. We've done a lot of focus on speaking. We could do more of that, or would you like to look at writing, vocabulary, grammar, and so on? So have a think about that. We're really grateful for you coming. We value input. Please complete the evaluation quiz if you have time. And let us help us plan future events. Thank you for coming.